Hello Year 12, and welcome to our first video here for our second topic. This is equations and linear functions, and today we're looking at solving equations. Now the fundamental principle that we need to apply with these is we need to keep the left hand side equal to the right hand side. We do that by making the same change to both sides. We're going to keep making changes until we can isolate that unknown, the x, the variable, the pronumeral, whatever we're going to call it. We keep making changes until we have that on its own on the left. We'll be done. So in the first instance here, the first example, we have a set of brackets that complicates things a little, so we're going to expand that first. And that's going to give us 3x minus 15 equals 18. Okay, that's the first step there. Now if I add 15 to both sides, the left-hand side will still equal the right-hand side. That'll give me 3x equals, now 18 plus 15 is 33. Now I'm going to divide both sides by 3, and 3x divided by 3 is x, and 33 divided by 3 is 11. Okay, and you can see there that we're done. We have a value for that unknown. One of the good things about solving linear equations is we can always substitute our answer back into the original expression to see whether it remains true. So if I put x equals 11 back in here, 11 minus 5 is 6, 3 6s are 18, the left hand side equals the right hand side. Let's have a look at the second example. And this time I have x's on both sides of the equation, so I'm going to subtract 4x from both sides. 6x minus 4x, and I might write that like this. Right, there's 6x minus 4x, and then I'm just left with 4 on the right. Or I might skip that line altogether and just go straight to 2x, because it is pretty simple, equals 4. Divide both sides by 2, again I could write that as both sides over 2, or I can just do that in my head, and I'm going to get x equals 4 over 2 equals 2. Checking that, 6 lots of 2 is 12, 4 plus 8 is also 12. See, and this is where they start to get difficult, or at least where students regularly experience difficulties once we introduce fractions into these. Now, there are a few different ways we might go about doing them, but I would recommend if we multiply everything by each of the denominators, each of the bottom numbers in the fractions, systematically, then we will get rid of all those fractions, and then we can go about using our other methods. So, if I multiply the left-hand side by 3, I'm just going to be left with 4x minus 6. Okay, I multiply the right-hand side by 3, and I get 30. Okay, from here it's looking fairly simple again. Now I've got 4x, I'm going to add 6 to both sides. Gives me 36, right, and gets rid of the negative 6 on the left. Now I'll divide both sides by 4, and I'm going to have x equals 9, right? Good practice to check that if you have the time. 4 9s 36 minus 6 is 30, divided by 3 is 10. Now here, in example D, we have two fractions, different denominators. That's fine. As I said, systematically we'll multiply throughout here. So the left hand multiplied by 5 is just equal to 3. And the right hand multiplied by 5, I'm going to write like this, 5 outside of x plus 1 over 12. Okay, that's my first step. There's brackets there to be expanded. We'll do that soon. Now I multiply everything by 12, both sides, and 3 12s are 36. And on the right hand side now, I will just have, the denominator will be gone, but I'm going to expand at the same time to save some space, and I get 5x plus 5. Now if I subtract 5 from both sides, I'll have 31 on the left and 5x on the right. And dividing both sides by 5, I'm going to have x equals, I've run out of space a little here, 31 over 5. Right, not such a neat and tidy answer, and a little harder to substitute back in to check. I've also flipped the left hand side and the right hand around. There right at the end, because my x just sort of happened in this case to end up on the right as we went along. Now, E here, a few fractions and multiple terms on each side. We have to be careful that we multiply each term by each of those denominators. So starting off here, we're going to multiply by 5, and that gives me 4b minus 5 equals 5b on 3 plus 30. Okay, we've multiplied each of those 4 terms. We've multiplied each of them by 5. Now I'm going to multiply every term by 3, and we won't have any fractions left. I'll have a 12b minus 15 here on the left, 5b plus 90 here on the right. Now we subtract 5b from both sides, and we're going to add 15 to both sides, right, to get rid of this negative 15 and this 5b. Right, we're going to get all of the variables, right, all the things with letters, all the terms with letters in them on the left, and all of the constants, those terms without any letters, on the right. So 12b minus 5b is 7b, and 90 plus 15 is 105, and 105 divided by 7 is 15. Rightio. Now, just one to go here. Multiply everything through by 7. I get 2x plus 7x over 2 equals negative 42. Now I'll multiply everything by 2, and I get 4x. Oops, my pen's going funny on me. 4x here plus 7x equals negative 84. That means that I have 11x here, negative 84 here, and x is negative 84 over 11. Can't simplify down. Might look like an unsatisfactory answer, but that's just how it goes. So, just to recap here, for solving linear equations, okay, whatever change we make to the left-hand side, we also make to the right-hand side. We make a series of regular changes, and that might involve expanding brackets and getting rid of fractions by multiplying, as well as adding and subtracting terms. But a regular set of changes until we're left with our unknown, which is often an x, equal to some constant on the right. Okay, if any of those don't make sense, please make a little note, ask your teacher in class. Okay, see you there.